Alright, so in this video, we're going to be learning how to identify direct and inverse variation equations. Direct variation equations can always be written as y equals k times x. And inverse variation equations can always be written as y equals k times 1 over x. And so, if we're trying to determine if an equation is direct variation or inverse variation, what we need to do is we need to be able to rewrite them in one of these two forms. So let's go to the first example and see if we can identify if it is direct, inverse, or neither. All right, number 1 says y equals 3x. If I look at this equation, this is already in our familiar form of y equals kx. And so there's nothing that we actually need to do to identify that this is in fact direct variation. This equation is already set up in that form. So if we recognize that form, then we know that it's direct variation. All right, number 2 says y equals 11 divided by x. We can re-express this equation as y equals 11 times 1 over x, because these are in fact equivalent equations. If I was to think about it in reverse, I could take the 11 and multiply it into the 1 and get back to what I started with. So I can see these two things are equivalent. Therefore, this is an example of inverse variation. Number 3 says x times y is equal to 4. And from this one, there's actually two different ways you could approach it. One way to approach it is to recognize that we have a product equal to a constant, which was effectively our secondary definition of inverse variation in the introduction video. So from there, right off the bat, you can see that's going to be inverse variation. Another way to solve it, or another way to determine that, is to divide the x over, giving you y equals 4 over x, and then recognizing that you can rewrite that in the same way that we rewrote the equation from number 2. And from there we can see that, again, this is in fact inverse. Number 4 says m divided by n is equal to 7. From here, we can also use kind of our secondary definitions from the introduction video and recognize that we have a ratio set equal to a constant, which means that that is direct variation. Now, if you're not certain about that, you can go ahead and solve this equation for m by multiplying each side by n, which produces a resulting equation of m equals 7 times n. And then again from there we can see that is also in fact direct variation. Number 5 says g is equal to negative 8 over d. I can rewrite this in the same way that I rewrote number 3. So I can re-express this as negative 8 times 1 over d. And I can see very clearly from there that that is in fact inverse variation. And finally, number 6, s is equal to t over 15. Okay, in the same way that I was able to break apart number 5 and kind of extract that negative 8 from the top of the fraction, I can actually also do that with my variable t. So I can rewrite this as t times 1 over 15. And what I have here is an example of direct variation that might seem a little strange. Let me rewrite my equation. So this might seem a little strange as direct variation, but all you have to do is recognize that we have a variable multiplying a number. 1 over 15 is a fraction. That's just like any other number. You could express it as a decimal if it's easier to see. But all we have is a constant times a variable. Oops. Times a variable. And so that is an example of direct variation.